What's up, everybody? We're back in room 301. So this video will not be as long. The good news is, and you'll only watch this after I've told you the good news, so it makes no sense to say, I will be here for the first half of the period, but this is a supplement that you could look at over the weekend or watch immediately after I leave, which will be at 2:30, halfway through the period. I want to go over just the general approach and the important things to know about graphing the 6 different trig functions, and then I will do 1, maybe 2 examples, depends on how long this all takes, and I just really want to give you the structure of when you start making a graph of a particular kind, what do you do? So started writing that out. We should think about these as the archetypes or the general formula for a sine or cosine function. I'll do it differently for the other trig functions. A, B, C, and D are just the letters that I use. I normally write x minus c, which just shows that the horizontal translations are in the opposite direction. But you should know what to do if you see x plus 2 and know that that's moving to the left. So I normally use those letters, and I will refer to the formulas with those letters, but sometimes you see it differently. So we have the amplitude, and I talked about how A is not technically the amplitude. Technically, the amplitude is the absolute value of A, meaning that if it were -2, I'd say the graph has an amplitude of 2. But if A is negative, we reflect that graph vertically, it flips over. Formula for the period involves B. Make sure that you've factored out B before you do that, so that you have also the correct phase shift, but we'll get to that. The formula for the period is 2 pi over b, whatever that number is. And the formula for the interval, I never use a letter for it. You put it right onto the graph, but I'll call it capital I, is the period divided by 4. This formula depends on if it's sine or cosine. Once we get to tangent, it won't be the same. But for every single trig function, the period divided by 4 is the interval. So then the phase shift, the way I've defined it is C. But I'll just give an example. X plus 2 would mean we move the graph left 2 units. Why not? Why not? Let's do a formula for the min and max. Oh, well, we also need the center line. That'll make more sense. The center or midline is y equals d. So we're going to draw that as a horizontal dashed line on the graph, and that's y equals d. In the answer key that I posted, which technically isn't mine, I do not see a y equals, but don't use that as an excuse for doing it on the test. I've already told you now 2 or 3 times y equals d. Half a point, look out. Center midline, and then the min would then be d plus the amplitude. Makes more sense on the graph, but will be, d minus the amplitude, sorry. Makes more sense on the graph. We're going to go up and down, and the max is d plus the amplitude. Min, max, center, midline. I think that's about it. So then, like I said, I'll just summarize. For cosine, start at phase shift off the midline, and if A is greater than 0, that means above at the max, and if A is less than 0, that means below at the min. Right, so if we have a positive amplitude, this is a normal cosine graph. Phase shift, and we're not drawing a full graph yet. A greater than 0, and A less than 0. right? So if I'm looking at cosine and I see that we have a positive amplitude or a positive A value, I'm going to start off the midline, but that means above. And if it's negative in front, like -2 cosine of x, it's going to start below the midline. Okay? I feel like I don't have room to keep moving right. So, I don't know. Am I on the screen right here?
You're good.
My hand is visible. All right, yeah, we'll do them next to each other. Sine. Start at. And by start, I mean put the first point that you decide to put on the graph at the phase shift. Start at the phase shift on the midline. I will start on the midline whether it's positive or negative, but for A is greater than 0. Next point is above the midline, which is a max. The next point to the right. I'll demonstrate that when I draw the graph. A is less than 0. Next point is below. And by that I mean, well, it would be crazy if we could still see right here, no?
No, you can.
Wow. Say the phase shift was here, I would start on the midline and I would go above. Oh, this is the dramatic moment where the camera people get to see that I was talking about sine and cosine, which they knew about and knew was triangular, about triangles. That's what sine looks like when you graph it, right? So this would be A greater than 0. We're starting on the midline at the phase shift, and if we had a positive number in front of sine, we'd be going up and then down and then back. And then trying to keep things different every time so that I don't have to do a bunch of example problems. There are a bunch of example problems. Negative sign. Those instructions should get you to where you need to go. If you provided that you put the interval correctly or calculate the interval correctly, you add the value of the interval to the phase shift and get tick marks on your number line correctly, you know the pattern is to go up and down or vice versa. And so these are your starting points for sine and cosine. Where should I go next, audience? Cosecant or secant?
Secant.
Yeah, why not? Why not? I'm going to try to conserve things. Secant. I think that actually makes plenty of sense because I'll change that to secant. It all makes sense. I'm going to do them kind of at the same time. Well, what do I have to check? Or what do I have to change, I mean? Not too many things. Not too many things at all here. The only thing that I will add is that we call this, as you know, Algebra 2 honors class, the fake amplitude. The reason for that is that this graph is not a wave, and so it doesn't have a traditional amplitude like sine and cosine do, right? So we're still going to do all of this. I think all of this applies. The period's still the same. And I'll even go over here. And start to make these dashed lines. And I'm going to add something. That would be secant, so good call. This would be cosecant, absolutely. Make a sine graph. First, make a cosine graph. First, keep it a dotted line. You can't tell me I didn't tell you. It's on YouTube. Make a cosine graph. It's not a solid line. And I just need to add one last bullet point, which would be vertical asymptotes where cosine hits midline I'll write a little note. Bounce. I'll do it. You'll see. The maxes and min. Add vertical asymptotes. So I've made the cosine graph already. I actually have. And then I draw vertical asymptotes where we hit the midline. So again, this is a dashed line if I'm graphing secant. And then I draw vertical asymptotes where the graph hits the midline, which is right here and here. And then I say bounce off of the maxes and mins. So this is the real graph that I'm drawing. And we're not curving up. Let's not be. Someone asked the other day, reasonable question, whether they should draw much else of that graph. If you were asked to draw one period, but be prepared to draw 2 periods, and then it will be unambiguous. This is like half of this portion of the secant graph, because we have only graphed this one period, and it does go up. We just didn't include that vertical asymptote. So then the other way around. And then going over here, looks a little bit different. I already can include 3 vertical asymptotes. This is the one that you can really get the full picture of. This is a graph of cosecant. Uh-oh, we're going into each other a little bit. It's okay, I think you can make it out. Hard to draw a dotted line over a solid line. But there you go. Like I said, in general, secant and cosecant, you're going to make the 2 graphs that we've already talked about. You're going to add vertical asymptotes, and you will draw those portions of the graph that bounce off of the maxes and mins. Where are we at time-wise? I got 2 more things. I think I won't do an example because I want to be able to do the examples outside of class, honestly.
We're 12 minutes.
We're 12 minutes, yeah. We'll see where we land. We'll do tangent and cotangent. Okay, so I will need to erase quite a bit here. I'll reset some stuff. Stuff on the left can be salvaged, but this graph is not the same. This is going to be tangent. And that's going to be cotangent. Okay, what do I have to fix here? A is still the fake amplitude. There is no amplitude for a real amplitude for tan or cotan. And even just to go back before I erase this is an amplitude, but we were graphing cosecant. And so this here, the value that I am away from the midline, is just something like an amplitude, a fake amplitude. It'll be the same in tangent. So A, the absolute value is fake amplitude. If A is negative, we do reflect vertically. But importantly, for the period, I have to go in and erase the 2 in the formula. Tangent and cotangent normally have a period of pi rather than 2 pi. Like I said before, the interval is not different. It's just divided by 4. Phase shift rules are the same. Center line is the same. We don't really have a max and min for tan and cotan. They do not have maxes and mins. They go asymptotically to infinity. Nor does secant and cosecant, actually. Okay. Tangent. Start at, I could have saved actually some of this. Start at the phase shift at the midline. On the midline? Let's say on. On the midline. Hopefully no one can see, because I'm blocking it, that I just spelled back wrong. We're going to see if that needs any adjusting in the wording. Start at the phase shift on the midline. Go back 2 intervals and forward 2 intervals. Try to do all of that. If A is greater than 0, the graph will be increasing. I don't know if I put it that way before, but I actually think that can help you visualize. But if A is negative, we are decreasing. Let's kind of work that out, all those instructions, as we draw a simple sketch example of a graph. So I will always go first to my phase shift. Let's pretend it was here. Maybe we saw x plus 5 in parentheses. That's my phase shift. It's actually nicer when you record a video. I can erase things right after, and if you needed to see it, you could just rewind. But then I say that we would go back 2 intervals and forward 2 intervals. So I'll put a couple more tick marks. 1, 2, and 1, 2. My full period does not happen after my phase shift, but 2 before and 2 after. Then, and I'm going out of order here, but let's not draw the whole graph. There are vertical asymptotes 2 intervals away from the midline, but 2 intervals away from where you hit the midline. And so that's where we have the phase shift. I have a midline in this graph. I know I've already said that I will put that point on the midline. Start at the phase shift on the midline, go back 2 intervals and forwards 2 intervals, and draw the vertical asymptotes at that distance away. So I said that it's increasing, and I'll say, like, we also have plus and minus the amplitude. Actually, the famplitude, fake amplitude. We are increasing, and so the graph will be going up as I go to the right. We go up and down by 1 amplitude, but we have to remember that there are vertical asymptotes for tangent, and that's the other place that we're going to go. You will only have 1, 2, 3 points on your graph because the 2 vertical asymptotes are taking away 2 of the points on that we otherwise have on other graphs where we have 5. And that seems decent. Right? We start at the midline. The only place to go is up 1 and down 1 amplitude, and then we go to the vertical asymptotes. That should be good. All right, we're almost there. It's feeling like this video is over when I finish cosecant, and we're not going to go through a whole example. I think that because I have time to do a couple today, and because we have such good answer keys to read, I think you don't need that. You need just a summary. You need me to put it into perspective. Okay, so a lot of things are similar in cotangent, but I should still write it separately. Cotangent, start, that's stat. You try to write and talk at the same time. Start at phase shift. Common theme, huh? Common theme, start at the phase shift. At a vertical asymptote. And let's say also next vertical asymptote is 4 intervals forward. We are at the midline. Halfway between the vertical, I've already written it twice, VAs. I have to go back and add a negative tangent, I suppose. And let's see if that's enough. Start at the phase shift. Phase shift is, now I'll move it right up and switching it around. Pretend the phase shift is here. We start at a vertical asymptote. We move 1, 2, 3, 4. I know I've said this a lot of times, but here it goes again. Tangent is the only graph where you will go forward and backward. Remember that. That is important for tangent. But every other graph that we've seen so far has gone forward 4 intervals after the phase shift. And there it is. Pretend the midline is here. Oh yeah? A is greater than 0, we are decreasing. And A is less than 0, we are increasing. Everything else sorts itself out if you put the vertical asymptotes at the right place. So, because I know that I'm going to be increasing, I can still place my point on the midline right in the middle. I've already drawn the vertical asymptote, gone forward, and I figured out where the halfway point is then. And now I can adjust for the fact that I am decreasing. And draw. And if I needed to draw another one, I would go back 4 intervals, go to the midline again, and do it again. This, by the way, is for A greater than 0. It's decreasing. So we've talked about in class how tangent and cotangent look very similar. It almost looks like tangent is just negative cotangent or vice versa. But because of the rule for where we put the first vertical asymptote, that really does not exactly work. They're shifted as well. Well, that's the positive ones. You will flip over. I said decreasing. Maybe it really isn't worth, well, all of that, and I could just do it. If A is less than 0 for a tangent graph, we will be decreasing like I said. And I think finally, if A is greater than 0, we will be increasing for a cotangent graph. Oh, less than, sorry. What do you think, you two? Sound good? All right, good.